All right, as we prepare for some circle questions regarding equations on Friday, here's 4 more practice problems in which you're not given the standard form of a circle. And once again, we like this form right here because it tells us the center, HK, it tells us the radius R. This form, the general form, doesn't tell us any of that information. If there's both a if there's both an x squared and a y squared, and they're both positive, and furthermore, this is interesting, if a and c are the same value, so like 4x squared and 4y squared. I think the ones we're giving you are just 1x squared and 1y squared. But if a and c are equal, it will be a circle. So you can kind of look at it and tell if it's going to be a circle. You'll learn more about that down the road. But it doesn't, looking at this doesn't tell us the, the radius. It doesn't tell us where the center is. This is a much more useful form, the standard form. So let's see how you did on this. Number one, um, the first thing that you should do every single time is you got to organize. And what that means is you need to collect your x terms and collect your y terms into a common location. And then for constants right now, I'm suggesting that you just totally clear them out, move them to the other side. You don't have to do that really, but I'm telling you, I see way more mistakes with people that don't. Now this only has one x term. It has the x squared, but it doesn't have a regular x term, so we don't have to complete the square for that guy. He's done. The y's though, right? I have this y squared and this y minus 6y, y squared minus 6y. And so I'm going to have to complete the square there. And so seriously, step one, and it's kind of already organized for you. The only thing you have to do is clear the 5 out, is do this little dance, organize it, right? Now we complete the square. So this is where you have to know that process. The middle term here is 6. So if we square a binomial, that's going to come from 2 terms that are exactly the same. So to know what that is, you better divide by 2. Negative 6y divided by 2 is negative 3y. And so what that means is the term in your binomial is going to have to be a negative 3. Negative 3 squared is positive 9. But if I add a 9 to the left side, I got to add a 9 to the right side. We call that balancing the equation. We've got to maintain the fact that this is an equality. And if you do something to one side and don't do it to the other, you lose that equality, right? And now we're done. We created this right here. This is a perfect square because if we foiled it into 2 binomials, it'd be y minus 3 times y minus 3. We made that happen by choosing this 9 to go there. And so that's y minus 3 quantity squared. And that is your equation of the circle. It tells us the center, h is 0. Looks like k is 3. And it tells us the radius, the square root of 4 is 2. So remember, this is not the radius itself, that's r squared. So if I go to 0 up 3, and then I go out in each direction 2 units, I get a nice little circle. So hopefully, number 1 for you look kind of like number 1 for me. Number 2, same game. Just kind of get used to the method. I've got x's here and here. I've got y's here and here. I've got a constant here. So what are we going to do? Step 1, we're going to organize. We're going to get our x's together, ready to complete the square. We're going to get our y's together, ready to complete the square. And we're going to clear that constant out, right? Negative 8 added will make it go to a 0. It ends up as a positive 8 on the right side of the equation. Now, I personally would be totally okay if you guys went from this step to this step because you're still organizing. You're just kind of pre-setting up the completing the square. I'm doing this a little bit more slowly because this is new for you, but I think you could go straight to that step because once you have things next to each other, you can complete the square. So half of 8 is 4 squared is 16. don't forget to add it to the other side. Do it right away. Half of 2 is 1. Squared is, well, yeah, still 1. Don't forget to add it to the other side. All right, so this is a perfect square. To get to 16, I multiplied -4 times -4, which when you add them is -8 in the middle. That's why it's a perfect square. This is going to be a y plus 1 times a y plus 1. Okay, and isn't that nice? We got 25 on the other side. That's a perfect square, isn't it? So that's your equation. We have now an h value of 4, a y value of, now this is plus 1, so it's actually a -1, right? The standard equation up here is always h minus h minus k, always minus h minus k. So if there's a plus in there, a negative would have had to been inserted to create a double negative. So that's the one thing you got to really watch out for. Square root of 28 and 5 is 5. So let's go over 4. Let's go down 1 and then out in 5 units each direction. Look at that. You are rolling. All right, here's number 3. We've got some x terms here and here. I'll tell you what, I've been using yellow for x. I'll be consistent here and here. So we're going to put those together. This one's kind of nice. We only have one y term. That means we do not need to complete the square for y. All right, cool. And then finally, we have our constant, which we're going to add 13 to both sides to clear that out. Now it's time to complete the square, isn't it? Half of 4 is 2 squared is 4 again. Don't forget to add that 4 to the other side, right? So this is x plus 2 times x plus 2, or x plus 2 squared, and we have our equation. It is done. The center is going to be -2 for h, 0 for k. So back 2, and then right on the x-axis. Now this was freaking people out a little bit. 17 is not a perfect square. So the square root of 17 is the square root of 17. It doesn't even reduce, it's a radical. That's okay. We know that the square root of 16 is 4. So the square root of 17 is going to be just a tiny bit more than that. In general, on non-calculator quizzes, which is what we have more than not, like in math analysis, on a problem like this, they would have to know that root 17 was just barely more than 4. They will always get credit if they're within 0.5. So I'll make one up real quick for you. Let's say square root of 30, right? So 30 is between 25 and 36. Those are the two perfect squares that surround 30. Square root of 25 is 5. Square root of 36 is 6. So we know that root 30 is just, somewhere between 5 and 6. But because 30 is just a tad closer to 25 than it is to 36, we would want to make sure we put it between 5 and 5.5, not between 5.5 and 6. And if they do that mental math, they get full credit. And so that's just something to think about. You should know that root 17 is definitely between 4 and 5, and that it would be much closer to 4 than it is to 5. Let's go to -20, but boom. And notice that we went just a tiny bit further than 4 with all of those points, okay? Do not be intimidated by radical numbers. You're going to have to get used to them. Look at this picture. You ever seen this before? Probably not, okay? What this is a way to create every possible rational number. Rational numbers, remember, are integers divided by integers. These are all the positives, okay? By using just the natural numbers, so 0 through 12 up to this point. And this would go on infinitely, right? Because there are infinitely many rational numbers. Now, here's why this matters, okay? Here's why this matters. You can create a one-to-one correspondence between the natural numbers and the rational numbers, which means that there's the same number of them. Now, that's weird because there's infinitely many natural numbers, and that means there's infinitely many rational numbers, but it's the same infinity, okay? Why this matters is that if there are infinitely many, say, rational numbers on this line right here, okay? This is just between 0 and 1. you could prove that there are more irrational numbers between 0 and 1 than there are um, than there are rational numbers everywhere, uh, which is implying that there's different sizes of infinity. It's called the cardinality of infinite sets, and um, the rational numbers are called countably finite, which means we can do this correspondence to keep track of them. You cannot do that with irrational numbers. There's too many of them. You can't keep track of them, and so it means there's more of them. So I know that in most of the time we're using nicer numbers, but the irrational numbers are all around us all the time. There's more of them than anything else. So I guess we should kind of accept them a little bit more. Here's your final question. Same game, different numbers. I've got some X's, so I'm going to group them. I've got some Y's, so I'm going to group them. Don't forget your signs, like, this 2x is being subtracted, so I'm going to make sure it's minus 2x, right? Move that positive 17 to the other side. It's now negative 17 because I subtracted it over. Half of 2 is 1. Squared is still 1. Half of 10 is 5. Squared is 25. Let's not forget to add the 1 and the 25 to the right side. Got to balance that equation. So this is x minus 1 squared. This is y plus 5 squared. And when I add everything up on the other side, it's 9. So hopefully that makes you feel good because we're back to perfect squares, right? So the center would appear to be 1, negative 5, and the radius is 3. So I'm going over 1, and I'm going down 5, and there's your circle. Hopefully, you're catching on to this. If you do enough of them, you will. If you're still not quite feeling it, there are 2 more problems on the worksheet tonight. You're doing the backside of last week's review worksheet 13 through 26. 25 and 26 are just like these. In fact, these are 2 of the problems that I'm going to have you turning into me. So, if you need help, make sure you stop by for help today. But that's what I'll be looking for. And good luck with your reviewing. Quiz day tomorrow. Rock and roll.